I want you to think about the last time your EcoBoost felt genuinely strong. Not just adequate, not just functional. I mean the way it felt when it was new, when you pressed the accelerator and the boost hit hard and clean, and the truck moved with a kind of effortless authority that made you understand exactly why you bought it. That immediate pressurized surge of torque that made a 6-cylinder engine feel like it had absolutely no business being this powerful. Now think about how it feels today. If you are being honest with yourself, there is probably a gap between those two answers. Maybe the throttle response feels slightly softer than it used to. Maybe fuel economy has quietly drifted down a few mpg over the past year without any obvious explanation. Maybe the idle is a little rougher on cold mornings than it ever used to be, or the truck feels like it hesitates just slightly before it gets into boost under hard acceleration. Here is what I need you to understand about that gap. It did not happen because your engine is worn out. It did not happen because something broke. It happened because your EcoBoost is being slowly strangled from the inside, and the process is so gradual, so invisible, so utterly silent that most owners adapt to it over tens of thousands of miles without ever realizing what they have lost. I have been working on turbocharged Ford engines for over 15 years. I have the same conversation with owners week after week. They come in with trucks that are running rough, burning extra fuel, losing power under load, throwing codes they cannot explain. And in almost every single case, the truck has not had a catastrophic failure. It has had its airflow progressively choked off at multiple points along the intake path, each restriction compounding on the others, until the engine is operating so far outside its design parameters that it barely resembles the machine Ford built. Today, I am going to show you every single choke point that is killing your EcoBoost's performance right now. I am going to explain exactly what is happening at each one, why it happens on these specific engines, and precisely how to fix it, including several things you can do tonight in your driveway with $12 in cleaner and 30 minutes of your time. By the end of this video, you are going to understand your EcoBoost better than most people who get paid to work on them. And you are going to have a clear action plan for getting that truck back to the way it felt the day you bought it. Let's get into it. Before we go any further, hit subscribe right now and turn on the bell notification. Every single week on this channel, I put out real technical content that saves Ford owners serious money, the kind of information that used to require knowing the right mechanic personally, or paying a shop $200 just to tell you what the problem is. It is completely free, it takes 1 second, and there is a very good chance the next video we put out will be directly relevant to something your truck is doing right now. Subscribe. Then let's talk about what is choking your engine. Hashtag a quick word on how the EcoBoost actually works, because it matters. Before we get into the problems, you need to understand something fundamental about how the EcoBoost engine family was designed, because this context changes how you think about every issue we are going to cover. The 2.7-liter and 3.5-liter EcoBoost engines were engineered around a single core principle: force more air into a smaller displacement engine than should physically be possible, and use that air density to produce power that has no business coming from a 6-cylinder engine. In its highest output configuration, the 3.5-liter EcoBoost produces 400 horsepower and 500 pound-feet of torque from a 6-cylinder engine. Think about that number for a moment. The way it achieves that is through a very specific chain of events. 2 turbochargers pull in outside air, compress it to a significantly higher pressure, feed it through an intercooler that strips the heat out of it to make it denser, and push that dense, high-pressure air charge into the cylinders where it allows far more fuel to be burned per combustion event than the displacement alone would allow. Every one of those performance numbers, every horsepower figure, every torque rating, every MPG estimate, every towing capacity assumes one thing above all others: a perfectly clear, unrestricted, uncontaminated path for air to travel from outside the truck all the way into the combustion chambers. The moment any part of that pathway gets compromised, the entire system starts degrading. The computer compensates as best it can. But every compensation has a cost-reduced power, increased fuel consumption, higher temperatures, accelerated component wear. And because each restriction develops gradually, you never feel a single dramatic moment of failure. The truck just slowly becomes a lesser version of itself, and you adapt to it without realizing what you have lost. Let's go through every choke point, starting with the one causing the most hidden damage and working toward the one you can fix right now, tonight. Choke point, #1. Carbon buildup on the intake, valves, the invisible thief stealing your power. This is the one nobody talks about at the oil change counter. There are no warning lights for it. There is no code that tells you it is happening. And it is built into the fundamental design of how these engines inject fuel. To understand why carbon buildup is an EcoBoost-specific problem, you need to understand the difference between port injection and direct injection. In a traditional port-injected engine, fuel is sprayed into the intake port upstream of the intake valve. Every time the engine runs, that fuel spray washes across the back of the valve, dissolving oil deposits, cleaning the surface, preventing any accumulation from taking hold. It is not glamorous chemistry, but it works beautifully. Port-injected engines can run hundreds of thousands of miles with intake valves that look nearly factory clean. The EcoBoost eliminates this entirely. Direct injection sprays fuel directly into the combustion chamber, bypassing the intake valves completely. Those valves receive nothing but blow-by oil vapor from the positive crankcase ventilation system oily mist that gets routed back into the intake tract, coats the back of the hot valve surfaces, and bakes into a hard carbon crust over time. Cycle after cycle, mile after mile, that crust builds up layer by layer. Here is what that crust actually does to your engine. The intake valve is the physical gateway between the intake port and the combustion chamber. When carbon narrows that opening, the turbocharged air that your EcoBoost worked hard to compress and cool has to squeeze through a physically smaller passage to get into the cylinder. The engine loses volumetric efficiency. Power drops. Throttle response dulls. Fuel economy decreases because the engine is working harder for less result. Cold start idle gets rough because the restricted valves create uneven airflow distribution between cylinders. And the most insidious part of all, it happens so gradually that you never feel a single moment of obvious decline. Your truck just slowly gets worse, and you adapt to the new normal without realizing how far it has drifted from where it started. The fix for existing carbon deposits is walnut blasting. A shop removes the intake manifold to expose the intake ports, then uses compressed air to blast crushed walnut shells against the valve surfaces. The shells are hard enough to strip carbon off aggressively, but soft enough that they cannot scratch or damage the metal underneath. When it is done correctly, the results are immediate and dramatic. Throttle response returns. Idle smooths out. Fuel economy improves noticeably. A walnut blast service costs between $500 and $1,000 depending on your shop and engine configuration. Most first-generation EcoBoost owners 2011 through 2016 need this somewhere between 50,000 and 70,000 miles. City driving, extended idling, and regular towing accelerate the accumulation significantly. But here is the part most people miss. Treating the carbon that already exists without addressing the source that keeps creating it means you will be back in that same shop paying for another walnut blast job and another 50,000 miles. The source is the PCV system continuously feeding oil vapor into the intake tract. The fix for the source is an oil catch can. Also called an oil separator, this device installs in line with the PCV hose and intercepts oil vapor before it reaches the intake system. The oil condenses in the can and collects at the bottom. Clean air continues into the engine. You drain the can at every oil change interval. Here is something that should tell you everything about how real this problem is. Ford Performance Parts developed and sells their own official oil separator kit specifically for the EcoBoost. Part number M676635T for 2017 through 2020 trucks, and M676635TA for 2021 and newer. Ford's own performance division built and sells an aftermarket fix for a problem that exists in Ford's own engine. That is not a subtle admission. Third-party catch cans from J&L, Mishimoto, and other reputable manufacturers are available at various price points and install without any permanent modifications to the truck. The installation takes about 30 minutes with basic hand tools. If you own a second-generation EcoBoost from 2017 or newer, Ford added port injection alongside the direct injection specifically to help combat valve carbon accumulation. The port injectors spray fuel across the valves at low loads to keep them cleaner. But the PCV vapor still enters the system and still coats the intercooler piping and charge air cooler with oil film, which brings us directly to the second choke point. Intercooler contamination, the problem that comes in two forms. The intercooler's job is critical and non-negotiable. Hot compressed air coming from the turbos carries less oxygen per cubic inch than cool compressed air. The intercooler strips that heat out, increases air density, and delivers a denser, more oxygen-rich charge to the cylinders. The EcoBoost's power and efficiency numbers depend entirely on the intercooler doing this job at full effectiveness. There are two distinct ways the intercooler gets compromised, and they affect different model years differently. Form 1. The condensation problem on 2011 through 2016 trucks. The original intercooler design on the first-generation 3.5-liter EcoBoost was so efficient at cooling the compressed charge air that under specific conditions, humid weather, sustained highway speeds. Heavy towing loads, the cooling process crossed a threshold that caused moisture in the compressed air to condense into liquid water inside the intercooler. That water pooled silently and invisibly at the bottom of the unit. Then the driver pressed the accelerator hard. The surge of boosted air sucked that accumulated water directly into the intake. Owners described it as the EcoBoost shudder, a violent stumble, hesitation, and sometimes a full drop into limp mode during hard acceleration. Check engine lights came on with misfire codes across multiple cylinders simultaneously. Ford issued Technical Service Bulletin 1381, addressing the problem by repositioning an air deflector inside the intercooler, raising the internal temperature just enough to vaporize condensation rather than allowing it to pool as liquid. If you own a 2011 or 2012 F-150 with the 3.5-liter EcoBoost and this service has never been performed, get it done. Replacement intercoolers from Mishimoto and other quality aftermarket manufacturers designed specifically for these trucks eliminate the condensation issue completely while actually lowering intake air temperatures beyond what the factory unit achieved. Form 2. Oil film insulation affecting all EcoBoost model years. The PCV oil vapor that bypasses any catch can you have not yet installed coats the interior walls of the intercooler with a fine film of oil residue over time. That film acts as an insulating layer, reducing the intercooler's ability to transfer heat out of the compressed air charge. The charge air temperature entering the engine rises. The engine's knock control system detects higher combustion temperatures and pulls ignition timing to prevent detonation. Pulled timing means directly reduced power output. The result is a truck that feels progressively slower and less responsive under load, even when nothing appears to be obviously wrong. No codes, no warning lights, no single symptom that makes you say something is broken. Just an engine that does not pull the way it used to, with no obvious explanation. A catch can that stops oil vapor from reaching the intercooler in the first place is the most effective long-term solution, preserving the intercooler's heat transfer capability at the level Ford designed it to perform. #chokepoint, #3. Dirty MAF sensors. AN throttle body, the fixes you can do tonight. This is where we get to the part of the video that costs $12 and 30 minutes and can make a genuinely noticeable difference immediately. The mass airflow sensor and the manifold absolute pressure sensors are the eyes of your EcoBoost's air management system. The MAF measures the volume of air entering the engine. The MAP sensors measure air pressure at various points in the intake tract. The powertrain control module uses all of these readings together to calculate the correct fuel delivery, boost targets, and ignition timing. When any of those sensors are coated with oil film from PCV vapor or contaminated with fine debris that passed through a degraded air filter, their readings drift from accurate. The computer is making fuel and boost calculations based on incorrect information. The result is an engine running the wrong air-to-fuel ratio under load power loss, fuel economy drop, hesitation and stumble during acceleration, idle quality issues. Here is the good news. Cleaning these sensors is one of the most immediately rewarding maintenance tasks on the entire truck. The MAF sensor sits in the intake air box near the air filter. 2 Torx screws hold it in place. Remove it. Spray the sensing wire element with dedicated MAF sensor cleaner. Allow it to air dry completely before reinstalling. Critical warning. Do not touch the sensing element with your fingers or any cloth under any circumstances. The wire element is extraordinarily delicate, and a single fingerprint leaves enough oil to cause inaccurate readings. The EcoBoost has 3 MAP sensors, one on the intake air filter lid, one on the charge air pipe before the throttle body, and one on top of the intake manifold. Owners who have cleaned all 3 at once consistently report getting measurable performance and fuel economy back without any other service performed. Use CarkMAF cleaner or an equivalent product that leaves 0 residue. The whole job costs about $12 and takes under 30 minutes. While you have the intake hose disconnected, look at the throttle body. On high-mileage EcoBoosts, PCV oil vapor coats the throttle bore and the throttle plate with a layer of carbon and oil residue that physically narrows the air passage and disrupts the smooth airflow the engine needs. The throttle body is the last gate air passes through before entering the intake manifold, and a dirty throttle body causes rough idle, hesitation off the line, and an idle that hunts for the correct RPM instead of settling cleanly. Spray dedicated throttle body cleaner onto a clean rag and wipe the bore and both faces of the throttle plate. Do not force the plate open against the electronic actuator motor. Let the cleaner work and use gentle wiping motions. A throttle body service at a shop costs $100 to $200. Doing it yourself costs $10 and 15 minutes. These 2 jobs together, sensors and throttle body, represent some of the highest return on investment maintenance available on any EcoBoost. #chokepoint #4. Boost leaks in the charge air system. The silent performance killer. This one does not announce itself. There is no dramatic symptom, no single obvious moment of failure. Boost leaks develop slowly, stay completely invisible to the eye, and can be completely silent at idle, which is exactly why diagnostic data consistently identifies them as the single most common cause of gradual EcoBoost performance loss and fuel economy decline. Here is what is actually happening. The charge air path runs from the turbocharger compressor outlets through the intercooler pipes, through the intercooler itself, through the lower intercooler piping, and into the intake manifold. Every connection along that entire path is a potential leak point. The rubber hoses connecting the metal pipes to the intercooler and to the throttle body are the most common failure points. Heat cycling over years of operation causes the rubber to stiffen and crack, and the clamps that hold them in position gradually back off under vibration. On higher mileage trucks, the plastic intake manifold itself can develop hairline cracks, particularly around the boss fittings where sensors and hoses attach. When a boost leak develops, here is the chain of events that slowly robs your truck of performance. The turbocharger compresses air and pushes it into the charge air system. The MAF sensor measures that air upstream of the leak, but a portion of that air escapes through the leak before it ever reaches the cylinders. The computer sees a mismatch between the air it expected to be in the system and the combustion output it is actually getting. It trims fuel delivery incorrectly. The engine runs lean under boost conditions. The turbos work harder trying to compensate for the pressure loss, generating more heat in the bearing housings and accelerating bearing wear. You may feel this as hesitation during hard acceleration, while light throttle feels completely normal. You may see lean condition codes or misfire codes. Or you may see and feel nothing specific, just a truck that has gradually lost its urgency over the past year with no obvious explanation. Diagnosing boost leaks properly requires pressurizing the charge air system. A smoke machine is the professional tool of choice. An aftermarket boost leak tester kit available online for about $30 does the same job for DIY diagnosis. It pressurizes the system at low pressure with the engine off, allowing you to listen for escaping air or apply soapy water to connections and watch for bubbles. The most common leak locations are the rubber intercooler couplers, the clamps at the throttle body inlet, and on pre-2017 trucks, the charge pipes themselves, which on some configurations have known weak flange designs. Replacing rubber couplers and hoses is completely DIY friendly and costs $50 to $150 and parts depending on your year and configuration. A full professional boost leak test and repair runs $200 to $500 depending on what the shop finds. If your EcoBoost has been slowly losing power without any obvious cause, a boost leak test should be the very first diagnostic step you take. Hashtag the bigger picture A&D. Your action plan. Every problem on this list shares one characteristic. None of them announce themselves dramatically. None of them produce a single obvious moment where you know something is wrong. They are all cumulative, gradual, compounding processes that rob your EcoBoost of what it was built to deliver so slowly that you adapt to the decline without ever realizing you are doing it. Your EcoBoost was designed and validated to specific airflow parameters at every stage of the intake path. Every performance number Ford published, every towing rating, every fuel economy estimate, all of it assumes clean sensors, clean valves, a clean intercooler, intact boost hoses, and a PCV system that is not coating everything downstream with oil film. When multiple choke points stack up simultaneously, and they always stack up together. Because they share common causes, the compounding effect on performance is far larger than any single restriction would produce alone. Here is your maintenance action plan going forward. Clean your MAF and MAP sensors every 25,000 miles. It costs nothing but a can of cleaner and 30 minutes. Install a catch can on any first-generation EcoBoost as soon as possible to slow valve carbon accumulation and protect the intercooler. Budget for a walnut blast service at 50 to 70,000 miles on a Generation 1 engine, and plan to repeat it if you accumulate miles quickly. Perform a boost leak test if your truck has lost power gradually without any code or obvious cause. If you own a 2011 or 2012 truck with a 3.5-liter engine, verify that the intercooler condensation bulletin has been addressed, or replace the intercooler entirely. Replace the air filter on schedule or check it right now tonight if you are not certain when it was last done. None of these are exotic procedures requiring specialized equipment or mandatory dealer visits. The ones you can do yourself tonight, do tonight. The ones that require professional equipment are not expensive relative to the performance they restore and the damage they prevent. Your EcoBoost is a genuinely remarkable piece of engineering. When every part of its intake system is operating the way Ford designed it to operate, this engine is hard to beat efficient, powerful, durable, and capable of well over 200,000 miles of hard use without complaint. Let these choke points stack up unaddressed, and you will keep wondering why your truck feels like a faded version of what it used to be, throwing money at symptoms while the actual causes keep compounding quietly underneath. Keep the air flowing. Everything else takes care of itself. Hashtag outro. If you made it to the end of this video, you now have a clearer picture of your EcoBoost than most people who get paid to work on them. You know where the restrictions hide, why they develop on these specific engines, what they actually cost you in real-world performance, and exactly what to do about every single one of them. The truck sitting in your driveway right now is capable of more than it is currently delivering. The only question is how long you let that gap stay open. Hit the like button if this video gave you something genuinely useful. Subscribe and turn on the bell so you never miss the next one. We put out real technical content on this channel every single week. No filler, no padding. Just information that makes your Ford better. Now here is my question, and I want your honest answer in the comments below. After watching this video and thinking about your own truck, which one of these best describes where you are right now? Pick one and tell me your situation. A. I have been dealing with rough idle. power loss, or bad fuel economy for months and had absolutely no idea any of this was happening inside my engine. I know exactly which of these choke points is my problem, and I am fixing it this week. B. I already had one of these services done walnut blast catch can boost leak repair, and the difference in my truck afterward genuinely shocked me. I want to tell other EcoBoost owners in the comments exactly what I noticed so they know what to expect. C. My truck feels completely fine right now, but after watching this, I realize I have probably been adapting to a slow decline and never noticed. I am checking my air filter tonight and ordering a catch can tomorrow. Drop your answer below. I read every comment. And if your EcoBoost is doing something specific that is not covered in this video, a code, a symptom, a behavior you cannot explain, describe it in the comments with your engine and model year, and let's figure it out together. I will see you in the next one.